More examples of integration by use substitution. The ones we're going to do in the videos today and the ones we'll do in Zoom class are less straightforward than the ones that we've been doing. And I want to emphasize that you don't have to see how things are going to work out with use substitution to begin. You're just going to always start off by picking u equal to the inside function. And the only function that I have in this integral that is inside another function is that square root that's inside the sign. So if this one's going to work by use substitution, it's going to have to be u equals the square root of x. Okay, so let's find our du. I need to change that to x to the 1/2 to be able to find the derivative. So du is going to be 1/2 x to the minus 1/2 dx. So I'm looking at that du. I know I've got to find that du somewhere in my integral if I'm going to do this by substitution. I don't see x to the negative 1/2 anywhere in my integral, so I'm going to rewrite that with a positive exponent and maybe turn it back into a root and see if I can find it in the integral. So let's rewrite our du. I'm going to put that x to the 1/2 down in the bottom with the 2, and then rewrite it as a square root. So my du is equal to 1/2 root x dx. So we're going to rewrite this integral in terms of u and du using u equals root x and du equals 1/2 root x dx. So when you first look at this integral, it's really tempting to say u is equal to the square root of x. So I have a u up here and I have a u down here. And technically that is true, and there's no rule against using your definition of u twice, but we actually need that square root of x that's down in the denominator to be part of the du. So let me erase that. I'm going to rewrite this integral in a helpful way. This is an optional step, but if it's helpful for you, then maybe it'll help you see how to do this. So I'm going to rewrite this as the sine of root x times 1/root x dx. So what I've done here is I've kind of unmultiplied two fractions. So if you want to think of that sine root x as being sine root x over 1, if I were to remultiply those fractions together, I would get the original integral. And I did that because that root x down in the denominator is actually an important part of my du. That du is going to need the dx. It needs that square root in the denominator to be able to be a du. It also needs a 2. I know I can do that, right? I can put a 2 down here in the denominator to make it 2 root x in the bottom. I put a 2 in the denominator, so to compensate, this time the 2 is going to be up in the numerator on the outside. And then that sine root x, this root x can be my u. All right, so when I put this all together, I'm going to get 2 integral sine u. And then this whole thing, the dx and the 1/2 root x together give me my du. Right, we know how to find the antiderivative of sine. It's equal to negative cosine. So this is going to be a negative 2 cosine u plus c. And we'll plug our square root of x back in for u. So negative 2 cosine root x plus c. Integral of secant pi x times tangent pi x dx. Again, when you're trying an integral by u substitution, you're picking u to be the inside function. The only thing that's inside anything in this function is pi x. Secant is not inside another function. Tangent is not inside another function, only the pi x. So if this is going to work by u substitution, it's got to be u equals pi x. All right, so let's figure out what our du is. Du, let's see, pi is just a constant. So if this was 3x, you would just take the derivative and get 3. It's pi x, take the derivative and you get pi. And we put our dx over on the right. All right, so let's see. All I need for my du is a pi dx. Pi is a constant. I can put a pi in my integral and I can put a 1/pi on the outside. That's just constant multiplication. I know that I can do that. And then my pi and my dx are going to be my du. Everything else in the problem I need to rewrite using u. And pi x shows up twice. I don't need either of those to be my du, so I'm going to make both of those into u's. It's okay to have more than one u show up in your u substitution integral. And let's see what we have left. So I've got 1/pi integral. Let's see, the pi and the dx are gone. They're going to be the du. And I've got secant u tangent u. And then we hope that that antiderivative is on my trig antiderivative list. If not, we'll just be stuck and we can't do things by u substitution this time. but secant times tangent is actually the derivative of the secant function. So the 1 over pi is going along for the ride. Antiderivative of secant u tangent u, it's just secant u. We're done finding antiderivatives, so we put our plus c, and now we can substitute back in that pi x. So I've got 1 over pi secant pi x plus c.